Okay, let's dive in. Perimeter, area, and circles are the topics we're going to look at today. We're going to start with perimeter and area. And the perimeter is the distance around a figure. So if we had, say, a rectangle and we were going to walk all the way around this rectangle, how far would we go? That's the perimeter of a figure, the distance around. This is a straight line distance. We're, even though we might turn here and there, we're walking in a straight line. And what I want you to think about here is a fence. If we think about a fence, then we're thinking about perimeter. Perimeter is measured in different units that are inches or feet or yards or centimeters or meters. Everything you'll notice there is raised to the first power because we're really just working in one dimension, straight line distance. And that's perimeter. For area, now we're not talking about the distance around a figure. We're talking about the amount of surface the figure covers. So if we were to look at a rectangle, we're not talking about the distance around it anymore. We're talking about how much space it covers. Instead of thinking about a fence here, I want you to think about a carpet. How much carpet would we have to buy if we were going to cover this entire space? A perimeter is measured in inches, feet, yards, centimeters, meters, because now we have length and width. We have two different dimensions. Now the units would be square inches, square feet, square yards, square centimeters, square meters, whatever the units are. When we're talking about area, our units are going to be squared because now we have two dimensions, length and width, instead of just perimeter is just a length. Look a little deeper into these rectangles. So if we want to find the perimeter and area of a rectangle, and let's go ahead and put some dimensions on here. Let's say that this rectangle is 3 feet long and 2 feet wide. So we have some dimensions on there. If I want the perimeter of this rectangle, there are a couple of different ways that I could do that. One, and this will work with all the figures we want the perimeter of, is imagine ourselves standing at one corner and walking all the way around the figure. If we walk all the way around that figure, however far we walked, that's our perimeter. So let's see here. We would have, if the bottom's 3 feet, then the top is also 3 feet. And if the right's 2 feet, then the left is also 2 feet. And so if I want the perimeter here, I just add up all those sides. It'll be 3 plus 2 plus 3 plus 2, which is, let's see, 3, 4, 5, 6, 7, 8, 9, 10. And this would be in feet. One thing I'll tell you about quizzes and exams, your answer will just be the number. It won't include the units. I want you to understand the units. I want you to know that it's feet. But because there are so many different ways you could type feet, it puts Canvas in a tough spot with trying to decide whether your answer is correct or not. So we'll just answer with the 10 and not include the feet. Another way to do perimeter here, if you really like formulas, is you could say, well, wait a minute, I'm doing the length twice and adding that to the width twice. And so for the perimeter of a rectangle, if you want to use a formula for that, it's 2 times the length plus 2 times the width for the perimeter of a rectangle. As far as the area of a rectangle goes, area of a rectangle is how much space it covers. So if we look at that, if this is 3 feet across the bottom and we want to go ahead and cut those, we want to cut that into 1 foot pieces. And not the most accurate, but you get the idea. I've got 1, 2, 3 feet here across the bottom. And then I want to cut it into 2 feet, go in the other direction. What I can see there is, well, I have 1 square foot here. I have another square foot here. I have another and another and another and another. How many square feet did I have inside this rectangle. How many square feet? Perfect. Lorraine, Natalie, Xochitl, Emily, excellent. 6. Yeah, I have 1, 2, 3, 4, 5, 6. So looking at this and seeing that my length was 3 feet and my width was 2 feet, and I ended up with 6 square feet to be my area, what's the shortcut? What's the formula we're going to use to find the area of a rectangle? Because I don't want to have to draw that and count up the little squares every single time. There's got to be a better way than doing that. Perfect, Carolina, you're exactly right. Length times width. So finding the area of a rectangle, we're going to use the formula length times width. To find the perimeter, you have a choice. You can use this formula, 2 times the length plus 2 times the width, or as you're going to see with other figures, you can sort of imagine standing in one corner, walking all the way around, and just make sure you add up all those exterior sides. That's perimeter and area of a rectangle. Does anybody have any questions about those before I have you try one? Okay, here goes. Find the perimeter and area of that rectangle. I'm going to set up a poll for this. We're going to kind of do a series of polls here today. We'll have quite a few of them. So we're finding perimeter and area. Perimeter is the first number, area is the second number. And like I said, we're going to look at several different figures. We're starting with rectangles. We're going to look at a couple more. And every time we do one, we'll kind of get our feet on the ground and then do a poll to make sure we've got it. Get our feet on the ground, do a poll to make sure we've got it. Obviously, whenever you have questions, I want you to ask those. But basically, how I'm going to sort of make sure that you're doing okay with all the figures we look at is just through the use of a poll. We'll go another 15 seconds on this one. Let me know if you need more time, then we'll talk about it. All right, let's see where we are on this one. Okay, perfect, unanimous. Kind of what I was hoping for, but you want to make sure. All right, so the first thing we were asked to find was the perimeter. And for perimeter, we could use the formula 2 times the length plus 2 times the width. If we do that, we have 2 times 13 plus 2 times 7. And then in doing this, we have to remember order of operations. Multiply goes before addition. So we would multiply and have 26 plus 14 and end up with 40. We don't know what the units are here. We just know it's 13 and 7. This could be inches, feet, meters, miles, kilometers. We don't know. We just know the perimeter is 40. The other way would be the top must be 13, the left must be 7. And a way to get the perimeter is just to add up all 4. 13 plus 7 would be 20, plus 13 would be 33, plus 7 would be 40. Perfectly fine. You can either use the formula or add up all 4 sides, whichever you prefer. For area, that's just length times width, which here that's 13 times 7, which is 91. So our perimeter is 40 and our area is 91. Let me know if you have questions on that before we move on to our next figure. Okay. Parallelogram. A parallelogram, you'll remember, has Top and bottom parallel, left and right parallel. Both pairs of opposite sides are parallel. And little rectangle shifted over. And that's how we're going to find our formula for the area here. We won't have a formula for perimeter of a parallelogram. For perimeter, we're just going to add up the sides. But for area, what we're going to do is sort of imagine with me for a minute that if I cut this triangle off, so I'm taking this triangle and I'm going to cut it off and I'm going to pick it up and I'm going to move it over here. So I'm taking this shape right here and I'm picking it up and I'm moving it, and you'll see how it fits perfectly right there. And so I picked it up and I moved it, and what I have now is a rectangle. So instead of looking at this as a parallelogram, I can say, hey, this looks an awful lot like a rectangle if I were to imagine moving that over. Now, the thing is, when we look at a rectangle, we're talking about these side lengths right here, the length times the width. And the bottom of our parallelogram right here, our rectangle and the bottom of our parallelogram are the same. The thing that's different though, this piece right here, this vertical piece, that's not one of the sides of our parallelogram. Let me get rid of some of my scribbles here. So what we're looking at when we look at that rectangle is we have this bottom part down here that we're going to call the base. And then this vertical part here, it's not one of the sides of the parallelogram, but that's what we need to find the area. We're going to call that the height. So when we go to find the area of a parallelogram, what we're going to do is base multiplied by height. So that's how we're going to find the area of a parallelogram. The perimeter is add up all four sides. The area is going to be the base multiplied by the height, and please keep in mind that the height is not one of the four sides. Any questions about that before I have you try one? All right, here goes. There's a parallelogram. Find the perimeter and area. I'm going to set up a poll for this one. Again, we don't have units. We're not concerned. They could be inches, miles, kilometers, centimeters. I don't know what they are. That's okay. We're after the numerical answer for perimeter and for area. And like I said, we're going to look at a bunch of different figures today, so we'll have a bunch of polls sort of throughout. We'll go another 15 seconds on this one, and then we'll talk about it. If you need more time, just let me know. See where we are on this one. Unanimous again. Outstanding. That's very good. If you're unsure of anything, please don't hesitate to ask. There's an easy mistake to make here that nobody made, which is terrific. First thing is, since this base down here is 10, then we know the top is also 10. This side on the right is 4, so this side on the left is also 4. So when we go to find our perimeter here, you can imagine yourself starting out anywhere, but I'm going to put myself in the top left, and I go 10 plus 4 plus 10 plus 4. And that's how we'll get the perimeter of this figure, is adding up all four sides. And that's 14 and 14 is 28. Very carefully, make sure you do not include that 3 in your perimeter. It's not part of the exterior of the figure, so it's not part of the perimeter, so we don't want to include it. Nobody did that in the poll, which is excellent. That's a really easy mistake to make. Now, as far as the area goes, that's going to be base times height. Our base is 10. Our height is 3. Kind of knew we were going to use that 3 for something. And our area then is 30. Let me know if you have questions on this before we move on to our next shape. All right. Triangle. If we look at that triangle right there, we can kind of imagine, we got to do that imagining thing again. This is where these formulas come from, a little bit of imagining. We're not going to prove them. We're just going to kind of see where they come from visually. If I look at this triangle and I draw this in, the triangle that I started with is half of a parallelogram. I know the formula for a parallelogram is base times height. And since this triangle is half of a parallelogram, then the formula for the area of a triangle is 1/2 times the base times the height. Because essentially what we have there with the triangle is half of a parallelogram. Perimeter, same idea as before. We're going to add up all the external sides. That'll give us the perimeter. Formula for the area of a triangle is here. Any questions on that before I have you try one with the triangle? Excellent. Here goes. There's a triangle. I'm going to ask you to find the perimeter and area of that triangle. Knowing how to find perimeter and area of all these different shapes is definitely something I want you to be comfortable with. As we practice them in class, if you have any questions, make sure you let me know. If you're doing well on these, then chances are you're in really good shape with these types of problems. And like I said, we'll have a whole bunch of polls today. We'll have some more later on in class. Doing those will give you a real good indication of how you're doing with the types of problems you can expect to see. We'll go another 20 seconds on this one and then talk about it. You let me know if you need more time. All right, let's take a look and see where we are on this one. Not unanimous, close, definitely strong agreement, not unanimous. All right, let's take a look. So first thing we've got to find is the perimeter. And for the perimeter here, we're going to imagine standing in one of the corners and walking the exterior of the figure. So that's 8 plus 18 plus 12. Be sure you don't include the 5 when you do perimeter because it's not on the exterior of the figure. And so we have 8 plus 18 plus 12. Let's see, and that's 38. So our perimeter is 38. Next, we need the area. For the area, we'll use a formula for the area of a triangle, which is 1/2 times the base times the height. So here, that's 1/2 times the base, which is the horizontal line in the triangle, that's 18, and the height, which is the vertical distance from the base to the highest point, and that's 5. So 1/2 times 18 times 5. Just a little bit of calculator remembering, just in case anybody's not so sure. 1/2 here, you could type it in as 0.5, that would be okay. Or this fraction just tells us to divide. That's just 1 divided by 2. So when we do 1 divided by 2, we'll have 0.5 times 18 times 5, and multiplying all that together gives us an area of 45. Again, we don't have units, so it's just 45. We've looked at perimeter and area of rectangles, parallelograms, and triangles. If anybody has any question about those, please let me know. Awesome. Here's a question that I think is pretty interesting. A right triangle has a hypotenuse with a length of 13 feet, and one leg has a length of 12 feet. What is the area of this triangle? There may be some people who are able to do this without drawing a picture. I wouldn't be one of them. So just to get myself comfortable, I'm going to go ahead and start by drawing a picture. So it says a right triangle. Okay, so I'll draw myself a right triangle over here. It has a hypotenuse with a length of 13 feet. Okay, hypotenuse is 13 feet. That's the longest side. It's across from the right angle. And one of the legs has a length of 12 feet. Okay, so this leg must have 12 feet. The question said, what is the area of this triangle? What I'm asked for is the area. Even though I just learned it, I'm pretty comfortable with the idea that the area of a triangle is 1/2 times base times height. So 1/2 times the base times the height. The problem is I don't know the height. So the first thing I'm going to have to do is find the height before I can answer this question about the area. My question to you is, how am I going to find the height? What am I going to use to find the height? One of those nice times for a math teacher where we're learning something new, but you're not really allowed to forget anything. That's always fun for us when we have to kind of call back to something that we've done previously. And Lorraine's probably got this. I just have to give her time to type it. But, oh, I got you. I won't judge you if you spell it incorrectly, I promise. Pythagorean theorem, that's exactly right. When we have a right triangle, we know leg squared plus leg squared is hypotenuse squared. And we're going to use the Pythagorean theorem here to find out h. After we find h, then we'll find the area of the triangle. So using the Pythagorean theorem, I would have leg squared plus leg squared is hypotenuse squared, or h squared plus, let's see, 12 squared is 144, 13 squared, 169. I'm going to have to do some work here to find out what h is. I'm going to have to subtract 144 from both sides. On the left-hand side, those cancel, leaving me with h squared. And on the right-hand side, I get 25. In order to get rid of squaring, I've got to take the square root on both sides. On the left-hand side, squaring and square root cancel each other out. On the right-hand side, I get 5. And I've just done a ton of work. I used a formula. I drew a picture. I've done all kinds of things. Kind of feels like Am I done? But I'm not. All I've done is find out that h here has a length of 5. What I still need to do is go find the area of this triangle. I love this question. The area of this triangle is 1/2 times the base times the height. And multiplying those together, we'll have 1/2 times 12 times 5 is 30. So the answer that we get to after all of that is 30. We drew a picture. We used Pythagorean theorem to find the height. Then we used the formula for the area of a triangle to find the area of that particular triangle. Are there any questions about what we did in that question? All right, fantastic. On to a new shape. Circles. First thing we're going to do is sort of talk about the anatomy of a circle. A circle, sort of a nice definition, is all the points that are equidistant from a single point. So a circle is all of the points that are equidistant from a single point. That single point is called the center. So we have a center of our circle. And essentially what we've done is we have a really long string and we stretch it out and we take that string out here and we'll draw in a circle. That's what we would end up with, where everything that's the same distance from that single point is a circle. A couple of things about the anatomy of this circle. If you remember, you can let me know. A line that goes from one end through the center all the way to the other end. Anybody remember what that line would be called for this particular circle? All right, I got a couple diving in. That's awesome. Shoot, so close. The radius is when we go from the center to the edge. That's the radius. Oops. There you go, Natalie, perfect. Yes, I figured, I know there's these two words that go with circles. And so from the center to the circle is the radius. All the way across, that's the diameter. So a center will have a radius and a diameter. That's funny. Yep, those are the words we'll need for a circle, is radius and diameter. So that's sort of the anatomy of a circle. This is what makes up a circle. We talked about perimeter and area of those other figures, so you kind of have an idea of where this is headed. We won't talk about perimeter with the circle, though. And the reason for that is because when we were looking at rectangles, parallelograms, triangles, those are all made up of line segments. They're all polygons, so they have a perimeter. A circle doesn't have any line segments in it. So instead of talking about perimeter, we're going to use the term circumference. It's the same idea that we had before when we had a shape, and it's the distance around. If I imagine myself standing up here and then walking all the way around this circle, how far did I go? The concept is the same. It's just with a circle, we're going to call that circumference. One thing that turns out to be true is if you find the circumference of a circle and you find the radius of a circle and you divide those, or excuse me, I got myself into it, and the diameter of a circle, there we go. If we do the circumference and we do the diameter, so we just measure these with a tape measure or a piece of string or whatever it might be. We measure circumference and diameter, and we do circumference divided by diameter. What happens is when we do that, we get the exact same answer every single time, whether it's a little bitty circle like this or a really gigantic circle like this. If we do circumference divided by diameter, we get the same exact answer every single time. That answer is 3.1415926, and it's a non-terminating, non-repeating decimal. It goes on forever. This discovery was something that the ancient Greeks made, that, hey, every time we do circumference divided by diameter, we get the exact same number. This is amazing. This is incredible. It was so remarkable to them that they decided to give this number a name. Anybody know what that name is? Outstanding. All kinds of people. Very good. That name is pi. And the Greek letter would be pi, or if you're a little fancier, pi, that way. It's the Greek letter pi. And basically, because this was such an amazing fact to the ancient Greeks, they gave that number a name, and it's pi. Pi comes up in the formulas we're going to use when we find the circumference and area of a circle. When we want to find the circumference of a circle, and essentially if we can see right here that if circumference divided by diameter equals pi, if we start with that idea and then we say, okay, well, I'm going to multiply both sides by diameter, those cancel, and I can see here that circumference is pi times diameter. So that's a formula for the circumference of a circle, is pi times diameter. One of the things that we saw earlier is that diameter is double the radius. If I have two radiuses, radii, then that's a diameter. So doubling the radius gives me the diameter. So this diameter here could be written as 2 times the radius. Let me know if you have questions about any of the things I'm saying. Diameter could be written as 2 times the radius. And so another formula we can use for circumference of a circle is 2 times pi times the radius. Essentially what we're saying there is this is pi multiplied by the diameter. We've just rewritten it in a different order. Honestly, I'm not exactly sure why. That's the more common way to write it, but it is. I'm thinking it's the idea that a number goes before a Greek letter goes before a variable, and because that's true kind of in both of these cases. But these are our formulas for the circumference of a circle. We can use either one. Kind of depends. If a problem gives us diameter, we'll use this one. If a problem gives us radius, we'll use this one. Neither one's better than the other. It just kind of depends on what information we've been given. And then as far as the area of a circle goes, the formula for that is pi times the radius squared. That's our formula for the area of a circle. You'll notice each one of these has pi in it. That's how important that number is. One thing I do want to mention about pi for our class, for our purposes, you probably have a pi button on your calculator. I don't want you to use it. Instead, I want you to use 3.14 for pi. And while that's true, that is an approximation. For us, we're going to use 3.14. And here's the reason. It's not that the pi button is wrong. The pi button is perfectly fine. It's just if we all do it the same way, then we'll all get the same answer. If you use your pi button, it's keeping all these decimals. So your answer might be slightly different from what you see in the book or what you see in the homework answers or what Canvas is looking for on a quiz. If we all just use 3.14 all the time, then we'll all get the same answer. I will tell you in advance, if you use a pi button on a quiz or on an exam and your answer's off by a tiny little bit, and then I can go in and tell that you used a pi button, please let me know, and I'll give you credit for your answer there. To save us that trouble, use 3.14 for pi, and then we'll all be getting the same answer every time. Are there any questions about any of these formulas related to circumference and area of circles before I have you try one? Excellent. Here goes. Find the circumference and area of a circle with a radius of 5 centimeters. And your homework, your quizzes and exams should give you this little reminder. Use pi equals 3.14, just to kind of refresh your memory that, oh yeah, if I use my pi button, it's not bad. There's nothing wrong with that. It's just my answer might be slightly different than the correct one according to the back of the book, the homework answers, or Canvas. All right, I'm gonna set up a poll for this one for you to find circumference and area. So circumference is first, area is second. We're looking for the circumference and area of a circle with a radius of 5 centimeters. You can see all my answers have been rounded to the nearest tenth. It didn't say that in the question, but since all the answers are set up that way, that's how we'll do this one. I think we'll go another 20 seconds on this. If you need more time, let me know. See where we are on this one. Okay, not unanimous, strong agreement, a little spread around. So let's be careful as we go through this one. Let me know if you see something that you're unsure of. You don't have to draw a picture of this circle, but I don't know, it kind of helps me to do it. So if we draw a circle and we have a radius of 5 centimeters, so this is what we're looking at here. And the first thing I'm supposed to find is circumference. So let's see, circumference. I could use pi times diameter, or I could use 2 times pi times the radius. And let's see, I was given the radius here, so I think I'll use this one. If you wanted to find the diameter first and then use the other formula, you absolutely could, but I'll go ahead and just use that formula there. And circumference is 2 times pi times the radius. And we're just multiplying these together. So we'll multiply right down the line. 2 times 3.14 times 5 is 31.4. You don't have to put units, but because we were given that it's centimeters, this is circumference. This is a straight line distance around the circle. So that's 31.4 centimeters. For area, we only have one formula for the area of a circle, and that's pi r squared. And so here the area is pi times the radius squared. One thing we have to do here is make sure to remember order of operations. We don't want to just go left to right through here. Instead, we have to remember, please excuse my dear Aunt Sally. So let's see what's in there. Parentheses are first. I have parentheses, but there's nothing to do inside them. They're just keeping things organized. There's nothing to do with parentheses. Exponents are next, and I do have an exponent. So before I do this multiplication, I need to raise 5 to the second power. So in simplifying this, the first thing we're going to do is raise 5 to the second power. So this 3.14 will stay put. 5 squared is 25. And now we'll do the multiplication. 3.14 times 25 is 78.5. This is the area. So this is how much space it covers. So our units here would be square centimeters. You wouldn't have to report units, but I do want you to be aware that they would be square centimeters. If you're thinking, how can you have square centimeters inside a circle? That's a legitimate question, but we could chop this circle up and have squares in it. And then if we counted up all these squares, and then you're going to have fractions of squares that you would combine with other fractions of squares to make a full one. And that's how you would wind up with 78.5 square centimeters inside this circle. What we got here for circumference was 31.4 centimeters, and for area was 78.5. Make sure to be careful with order of operations on this one, on this formula down here. Are there any questions about that? Before we get another question that's a little more challenging than just finding circumference and area. Okay. If the circumference of a circle is 28 inches, what is the area? Use pi as 3.14, round your answer to the nearest tenth. So this time it doesn't say, here's what your radius is, find circumference and area. This time the question says, if you know what the circumference is, find the area. All right, well, I'm going to be asked to find the area, and I know the formula for area is pi r squared. So I think what I'll do here then is use the formula for circumference that uses radius. That way, I've got radius in both formulas. You don't have to do it that way. You could do circumference as pi times d if you'd like. Eventually, you'll find the radius and get to the same place. So what I'm told here is the circumference is 28 inches. Well, this is what I know about circumference, so let's see if I can use that to get me on the road to my correct answer. So if I know the circumference is 28, 2 times pi times r. I was told to use pi as 3.14. So 28 is 2 times 3.14 times r. Oh, okay. Essentially, what this goes back to is I've got this formula here that has 2 variables in it. If I know one of the variables, I can find the other one. In the last problem we looked at, we knew the radius, so we could find the circumference. This time, it's just reversed. This time, I know the circumference, so I can find the radius. I just need to solve this equation right here for r, and I'll know what the radius is. After I know what the radius is, then I can go over here to this formula to find the area of the circle. So let's go ahead and solve this. Let me know if you see anything that doesn't make sense. I'm going to clean up the right-hand side here. 2 times 3.14 is 6.28. And let's see, I'm trying to get r by itself. That's multiply, so I'm going to divide by 6.28 on the right so that those cancel. If I divide by 6.28 on the right, I've got to divide by 6.28 on the left. And so these cancel, leaving me R. And on the left, I've got, let's see, 28 divided by 6.28, which is this really long decimal, 4.4585, and it just keeps going. The problem tells me to round my answer to the nearest tenth, but I'm not to my answer yet. I don't want to do any rounding until I get to the very end. So what I'm going to do is I'm going to keep this really long decimal here on my calculator. I'm going to leave it sit there. And now I'm going to use the formula for the area of a circle to find that. The area is going to be pi times the radius, which is that really long decimal, squared. Well, the good news is I've still got that really long decimal sitting on my calculator, so I can go ahead and square it. I still get a crazy long decimal, but that's okay because I only have one thing left to do, and that's multiply by 3.14. At this point, I have 3.14 times 19.87910. I'll multiply that by 3.14. And the area I get is 62.4203. And now I'm done calculating. I've done all the calculation I need to do. Finally, I get to round this to the nearest tenth. So I'll find the tenths place. I'll look one space to the right. That's 4 or lower. So we'll round this down to an area of 62.4. This was in inches, so this would be square inches. Your answer on a quiz or an exam, though, would just be the 62.4. I'm just going to talk back through what we did there. We were given the circumference. We wanted to find the area. We can't really go straight from circumference to area without sort of an intermediate step of finding the radius first. And so that's what we did. We used this formula for the circumference of a circle to help us figure out what the radius would be. Then once we had the radius, we could use that in the formula for the area of a circle. Not the prettiest calculation in the world, but that's okay. Our calculator can hold those ugly decimals for us, especially in a case like this where I have the radius, I need to square it, and then multiply it by 3.14 to get to our answer, and then make sure to round carefully, however you're asked to round. I think that's a fairly challenging question, actually. Probably the most challenging thing we've seen so far today. Are there any questions on what we did there in that one, or anything, honestly, with rectangles, parallelograms, triangles, circles? Okay, terrific. Composite figures. This is where we're looking for the perimeter and area of something that isn't just a rectangle, triangle, parallelogram, or circle. Now we're looking for a composite figure. It's pieces. Like if I want the perimeter and area of this thing, I don't have a formula for the perimeter of an L shape. I don't have a formula for the area of an L shape. Instead, what I need to do, well, perimeter, that's the distance around. So I'm going to imagine myself standing up here in this corner and walking around the figure, and I'm going to add up all the sides. I do have a little bit of a problem here, though. This figure didn't give me the length of this piece, and it didn't give me the length of this piece. Before I can find the perimeter, I'm going to have to know those side lengths. So I'm going to ask you to help me out. This length right here, how far is it? What's the length of that line segment? Outstanding. Very good, Nicole, Carolina, Lorraine. So if I look at the horizontal distance from all the way over here on the right to all the way over here on the left, that's 10. If I look at horizontal distance from here to here is 2, and I can sort of imagine that being right here, and that would have a distance of 2. And so to make up the rest of that distance, the length of that side has to be 8. essentially what I did was 10 minus 2, but this side length has to be 8. Using similar logic with the vertical side lengths, how long is that piece? Very good, Lorraine, Nicole, and I hope everybody's with them. Vertically, this is 4, and I can imagine that 4 being right here, and so the vertical distance from bottom to top is 7, and so what that tells me is that this side length is 7. Now I know all the side lengths, and I can find perimeter. Perimeter of this figure, let's see, will be 2 plus 3 plus 8, 4 plus 10 plus 7. So we'll add all those together. 2 plus 3 plus 8 plus 4 plus 10 plus 7 is 34. So the perimeter of this figure is 34. And here, I don't know what the units are. Inches, feet, yards, miles, centimeters, kilometers. I don't know. Just 34. For area, I don't have a formula for the area of an L shape. So what I'm going to need to do is cut this into smaller pieces, find the area of those, and add them up. The way that I'll cut this one, and I may even do it both ways. We can cut it here into a rectangle right there, and then also cut it into a rectangle here. And if I find the area of the orange rectangle, find the area of the red rectangle, and add those together, I'll get the area of the whole figure. So for the orange one, I have length times width here. That's 10 times 4. That's 40. And then in the red rectangle, I have to be careful to make sure I use the right side lengths. I get 2 times 3, which is 6. And so the area of the entire figure will be 40 plus 6, or 46. And it would be square inches, square feet, square yards, square miles, whatever they are. One thing I do want to show you here is I cut the rectangle, or I cut the L shape into rectangles that way. You might think, well, I didn't see it that way. What I saw was cutting it into a rectangle here, and then another rectangle over here. Well, that should still work. I mean, it's the same shape that we're cutting apart. When you do this, it's totally fine. Just be careful with the side lengths that you use when you find the area of those pieces. Now, my width is 2, but my height isn't 3 anymore. Now my height of this rectangle is the 7. So this area would be 14. And then when I look at the orange rectangle, sure, the height is still this 4, but the length isn't 10 anymore. Now the length of this rectangle is 8. And so I'll have 8 and 4. This has a area of 32. And so altogether, the area of my shape will be the 32 plus the 14 is 46. Sure enough, it's the same thing I got the other way. It better be. So there's not a right or a wrong way to cut the figure up. Just make sure you're careful when you decide what side lengths you're using. We didn't want to use the 10 this time. We didn't want to use the 3 this time because those weren't the side lengths of the rectangles that we made. Does anybody have questions on that before we look at another one that I'm going to let you try? Okay. Find the perimeter and area of this figure. First thing I'll say about this one is we have a couple side lengths missing there that we're going to have to find the length of those sides before we can do anything else. Then we'll be able to find the perimeter. And then as far as area goes, there's a couple of different ways you can cut this up. Whichever way makes sense to you is how you should do it. And this one takes a little more time than the others. We've got to find those missing sides, then we've got to find the perimeter, then we've got to figure out how we're going to cut this up. And then after we've cut it up, figure out what the area of the entire figure will be. I'm thinking we'll go another 45 seconds on this one, and then we'll talk about it, and you can let me know if you need more time. Okay, let's take a look. Okay, unanimous. That's a good thing. Not as many people answered as previously today, so either that's confusion or exhaustion, or maybe a little bit of both. You let me know if you see anything in here that doesn't make sense. We're going to go ahead and talk through it. The left-hand side has a height of 7, so does the right-hand side, so that one comes pretty easily. This piece right here is a little more challenging. As I look at the horizontal distance here, all the way across is 16, and let's see, what I've got is, I've got 4 plus I don't know how much plus 1. That's what makes up my entire horizontal distance. So if I do 16, if I take away 4, that's 12. Take away 1 more, that's 11. And so this length must be 11. Now I've got all the side lengths, I can find the perimeter. Our perimeter here, and it doesn't matter where you start, just sort of make sure you don't count anything twice and make sure you count all the sides. So I'm going to start there, and this will be 4 plus 3 plus 11 plus 1 plus 7 plus 16 plus 7. All right, let's see what that gives us. 4 plus 3 plus 11 plus 1 plus 7 plus 16 plus 7 is, oh, I am. I'm totally missing one. Thanks, Lorraine. See there? That's exactly what I said. Make sure you don't miss any. There's this side length right here that we didn't find. Luckily, I've got a 3 right here, so that's also going to be a 3. Once we put that 3 in there, now we have all of our side lengths. We can go in and find our perimeter. So now we'll find our perimeter for real. And that'll be 4 plus 3 plus 11 plus 3 plus 1 plus 7 plus 16 plus 7. So make sure you're careful about having all the side lengths and not missing any. Now we'll add this up. 4 plus 3 plus 11 plus 3 plus 1 plus 7 plus 16 plus 7 is 52. So our perimeter is 52. Now we want to find the area of this entire thing. And I'm going to start by chopping it up into smaller pieces. And you may have seen this differently. What I see is a big long rectangle down here, and then a smaller rectangle in the top left, and then a smaller rectangle in the top right. But you can cut it up a different way and still get the correct answer. We saw that in the previous one. Up here, I'm 4 by 3, so that has an area of 12. This is 1 by 3, so that has an area of 3. And then down at the bottom, it's 16 by, I don't know how long that is. Well, let's see here. If all the way from bottom to top is 7, and from here to here is 3, then this part left over right here must have a length of 4. And so when we go to find the area of that blue rectangle at the bottom there, what I'm going to need to use is 16 and 4. And so that has an area of 64. And then to find the area of the entire figure, we'll have the 12 in the top left, plus the 3 in the top right, plus the 64 at the bottom. We'll add all those together and get 79 for the area of the whole thing. The poll went great. I just want to give anybody a chance to ask questions that may have them about what we did to find the area and the perimeter of that figure. Okay. Here's one that's kind of fun. Find the area of the shaded region in the figure below. You may remember this from an algebra class somewhere along the line where it was where there were variables involved. We're not going to do that, but essentially what we've got here, is we've got this swimming pool, and we have a walkway that goes around the swimming pool, and what we want is the area of the walkway. How am I going to find the area of just this stripe right here? Like, I can find the area of a rectangle, but I can't find the area of a chunk of a rectangle. What am I going to have to do? And a one-word answer might do the trick. Perfect, Lorraine, you're exactly right. What I can do, I can find the area of this big rectangle, the 9 times 5. So the area of the big rectangle is going to be 9 times 5, or 45. Then what I can do is find the area of this small rectangle on the inside, which is 7 times 3, or 21. And then, exactly as Lorraine suggests, I'm going to subtract. Because if I take the area of the big rectangle, the whole thing, and then I subtract the small rectangle from it, what I'm left with is the area of just that shaded region. So we'll do 45 minus 21 and find out that the shaded region has an area of 24. A little bit of problem solving skills makes that into a much easier question than it might first appear. And that's a really important idea in this section. One more for you to try today. Rounding to the nearest hundredth, find the area of the figure shown below. And we have this Pac-Man shape. And it's certainly related to a circle, but it's not an entire circle. It's just a fraction of a circle. It's a fraction of a circle, and that's what we're going to do to find the area of this partial figure. This one may be challenging. We'll see how it goes. I'm going to set up a poll for it. This is our last poll for today. And the idea that this is a fraction of a circle, that's what's going to lead us to our correct answer here. But this one I'm a little curious to see how it goes. And like I said, this is our last poll of the day, last problem of the day, really. I just have to do a little bit of some hints about the homework after we do this one. Like I said, lots of different topics today with the rectangles, parallelograms, triangles, circles, and then composite figures, and now partial figures. So a bunch of different topics today, but our polls went really well. My thought was that you would do a great job with the different content we saw today, and that was definitely true. We'll go another 30 seconds on this one and then talk about it together. Let's see how we're doing on this one. Not unanimous, but close. That's really good because I wasn't sure if this one would be challenging or not. Turns out you did really well with it. So what we see here, and what's an important part of this is, when we look at this figure and we can kind of see, well, it's the better part of a circle. And if we were to cut this circle into 4 parts, it's 3/4 of a circle. So what we have is 3/4 of the entire circle. And the area of an entire circle would be pi times the radius squared, which would be 3.14 times this radius that we've been given, squared. And so that's 3.14 times 16, which is 50.24. So if we had an entire circle, our area would be 50.24, but we don't. We have 3/4 of a circle. So the area of our shaded picture over here is just going to be 3/4 of, which is multiply by 50.24. 3/4, you might know it as 0.75, or you could do 3 divided by 4 to get 0.75, multiply by 50.24, and that gives us an area of 37.68 was the area of that Pac-Man shape that we had over there. Are there any questions about that one? Before I talk about the homework just a little bit, and then we wrap it up. All right, a couple of homework notes for today. Question number 12 in the book, when you read it, you may not be sure exactly what's going on there. What's going on in number 12 is you're starting out with a square fence. You're going to tear that down and then use the same amount of fence to build a circular fence. So that's what's going on in number 12. We start with the square fence, we tear that down, we use the same material to make a circular fence. And then in number 13, it's just a hint related to the Pythagorean theorem. And I'll go ahead and really help you out with a hint in that one, that where the Pythagorean theorem leads us there is to x squared plus x squared equals 12 squared. And that should be a hint that helps out a lot for that particular